for two functions we have to figure out their inverse. Well, that's not horrendously difficult, because remember, what is an inverse? Well, an inverse is just retracing whatever a function does to us, right? If we've got an f machine that takes in an input x and spits out an output negative x plus 4, our f inverse machine is instead going to take inputs that do something to its own inputs that exactly opposes what this guy does. So if you take this minus x plus 4, so what we know for sure is if you need this thing to be such that if you put in minus x plus 4, it will spit you back out x. Now, what has been done to minus x plus 4 to make it spit back out x? So what happens to its inputs? Inputs, of course, don't have to be x. The inputs to a function can be mystery pretty lemony letter with, and when I say mystery, I do mean it, so I'm going to go ahead and cut a little hole in our donut. Oh, I said I'll cut a little hole, and then I proceeded to just wipe it out of existence. There we go. Yeah, there we go. So what happens to our mystery donut? What happens to our mystery donut when it is entered this fraction? Well, we know what happens to mystery donut is if it's entered into f. If you enter a mystery donut into f, shloop, punch a hole, and then what you end up with, well, you end up with mystery donut man, or mystery donut input, negated and 4 added. Negated and 4 added. So we're trying to figure out, given their outcome, what to do to this outcome to go back to where we were. So let's give this outcome a name, because we're really clever. We're going to call it R for the result. So the result is equal to negative x plus 4. That means negative x, because what we want, of course, is given the result, we want to figure out the input. So we want to figure out the input in terms of the outcome. We're so far, going from here to here, going this way. We know the input and we're trying to figure out the output, but trying to retrace our steps, given a certain output, given mystery man and donut, given negative x plus 4, we have to go to x. So given donut, what do we have to do to donut to figure out what happened before he was dropped into the function? After donut was dropped into the function, we ended up with negative x plus 4. But if donut himself were to be the result of f of x, what would have produced, what input into f of x would have produced a result of donut? That's what the inverse function is asking. So yeah, let's retrace our steps, figure out what we need to do to our input, what we need to do our output, and what we need to do to our output in order to figure out what input notification is. So r is equal to negative plus 4, then negative x is equal to r minus 4. X is therefore, multiplying both sides by negative 1. X is therefore equal to 4 minus r. So this input is equal to, so this input is equal to 4 minus the output that equation did. So in order to figure out what we did to here, what we did to this guy, we have to take the input that we're given to this function. So we take the result, right? We take the result, we negate it, negate minus x plus 4, and then we add 4 to it. What's the negation of minus x plus 4? Well, the negation of minus x plus 4 is just x minus 4. So if we again go ahead and add 4 to x minus 4, we end up with just x. Aha. So indeed, this is the correct procedure. If you take a certain input, negate it and add 4, you will end up undoing what negating it. You will have undone what negating that input, what negating the effect that we would have originally happened by taking an input, negating and adding 4. So that means our inverse function, our pretty inverse function, is the following. Takes in a certain input, call it x, and gives you 4 minus x. So as a result, if you throw anything into the f machine, and then you take that result from the f machine, plug into the f inverse machine, then the answer that you're going to get is going to be the original input that occasioned that result from the f machine, because the f inverse machine has the nice property of undoing precisely exactly what the f machine is trying to do. But it's important to keep in mind that just because they're both expressed in terms of x doesn't mean they're all getting the same inputs. X is just a placeholder. It's just a name for the input. Wherever you see an x, you have to replace it with whatever the input is. X could have just as easily been, we could have called it star, we could have called it Snow White, and it would have all given us the same answer anyway. So what do we have? We have g of x equal to 3x minus 6 over 2. So g of x equals 3 over 2 x minus 6. That means we have some result over here. The result, the outcome, is equal to 3 over 2x minus 6. So given the outcome, how can we trace our steps back to figure out the input? Well, 3 over 2 times x minus 6 is equal to r. R is therefore equal to 2. Therefore, x minus 6 is equal to 2/3 of r, multiplying both sides by 2/3. If x minus 6 is equal to that, x is equal to 2/3 of the outcome plus 6. So if you take an output, take 2/3 of that output, and then you add 6, you're going to be able to figure out the input that produces the output of 3 over 2 times x minus 6. So the inverse function, if it truly wants to negate everything, g stands for, it should go ahead, take an input, call it x. It doesn't have to be x, the input can be called anything. It will take that input, spit out 2/3 of that input plus 6, because this will undo everything the g function does. So these two functions have the nice property that if you, go ahead and substitute in any input, you take this output and you plug it into the other function. You take an input, get this output, plug it into the other function. The input is going to come out unscathed and unchanged because these two functions undo each other, hence they're inverses. They retrace the steps that the other one takes.